All right. Yesterday, you may or may not recall, we were talking about section 5.1. That was the fundamental theorem of calculus, the FTC. That said that if you want to take the definite integral of a function on some interval, or the area under the curve, all you got to do is first integrate the function. So that would turn f into what they used capital F for that. Integrate the function using whatever technique you used to integrate, usually power rule for us. And then plug in your limits of integration and subtract. So first you plug in the upper limit, then you plug in the lower limit and subtract the two. This will give you the area under the curve of a function on some interval. We don't have to worry about plus c's with definite integrals because you would have a plus c in each of these two terms, and since you end up subtracting, the plus c's go away anyway. We are going to parlay that into today's lesson, which is 5.2, cleverly called the second fundamental theorem of calc. We're going to use that second FTC to find the derivative of an integral, or sometimes the integral of a derivative. And if those two things to your ears sound like they should cancel out, you are over halfway there already in understanding second FTC. So let's start with an example that we can already do. Let's start by getting the derivative of this antiderivative, this definite integral. To do that, we're going to start by integrating. We're going to integrate t squared, and we can use power rule for that. We would simply go up a power over the power. We'd get t cubed over 3. And because it's a definite integral, fundamental theorem says you can plug in your limits of integration and subtract. So in plugging in this upper limit, instead of t cubed, I literally get x squared minus 1 cubed over 3. In plugging in this lower limit, instead of t cubed, I get 1 cubed over 3. So this is the result of the integration. Again, I'm not going to worry about the plus c. That happened. There was a plus c here and a minus c here. They're going to cancel out. But now I still have to differentiate the result. So before I do that, I'm going to write this first term as 1/3 quantity cubed minus 1/3. When I differentiate this, the 1/3, I can keep that as a constant and just differentiate the variable portion. I would get, using chain rule here, I would get x squared minus 1. I would drop, I'd bring the 3 down. I'd get x squared minus 1. I'd keep the quantity the same, and I'd drop the power to 2. I would then chain on the derivative of the inside, which would be 2x. In differentiating the 1/3, I would get 0, because the derivative of a constant is simply 0. In cleaning this up, the 1/3 times 3 gives you 1, so really I just have x squared minus 1 quantity squared times 2x. That would be the derivative of this definite integral. Now in a moment here we're going to look at what the second fundamental theorem actually says, and then we're going to use second fundamental theorem to do this same calculation. We should, of course, therefore end up with the same thing.